In this video, we're checking out how to factor out a greatest common factor. So sometimes when you're looking at a trinomial, all three terms will have something in common, and we want to factor that out before we try to turn it into two binomials. It'll make it easier. You'll see as we go. Now, before we look at an example, I want to just give you some insight into how I'm coming up with these example problems. Okay, so if I were to come up with an example of a trinomial that has a greatest common factor that we could factor out, it would look something like this. First, I would start with two binomials, x plus 2 times x plus 4. If I multiply those two together, I'll get a trinomial. What I want to do is now insert a greatest common factor into that trinomial, like 5. Okay, let's see what happens. Now I multiply x plus 2 times x plus 4, get my trinomial. You know how to do that. And what I'm going to do now is distribute that 5 to the three parts. 5x squared minus 10x minus 40. Now I've got a trinomial where the three terms have something in common. In this case, a 5. Alright, now let's work that backwards with this one. 3x squared minus 9x minus 30. First, just think about what is the greatest common factor. Okay, once you got it, in this case, pretty easy to spot. It's a 3. What we're going to do is divide each of the three terms by 3. That's how you factor out the greatest common factor, is dividing by it. Okay, so now the way we're going to write that is a 3 in front of an open parentheses. Now the three terms inside the parentheses are after we divide by 3. So x squared minus 3x minus 10. Okay. Then our next step is just to factor the trinomial into two binomials. So there we're looking for two numbers that multiply to negative 10 and add up to negative 3. If you need a little help on that one, you can look back to the other 8.2 video, which is factoring easy trinomials. Okay, now what I want to do is also look at the other method that we had for doing this. So if we want to factor a trinomial and we're not sure if there's a greatest common factor or not, you could always use the area model that we use to do any of the other trinomials. Okay, so you make your box with your 4 pieces, put the first term in the upper left, the last term in the bottom right, and we want the other two boxes to add up to negative 9. Okay, so 3x times x gives us 3x squared. That was our only option there. Now with negative 30, we've got a few options. We could multiply 10 times 3, 2 times 15, 30 times 1. So where do we go? Well, if you're using this method, you kind of have to use guess and check. So we'll guess negative 10 times 3 gives us negative 30. Alright, if we do negative 10 times x, that's negative 10x. 3 times 3x, that's 9x. And 9 plus negative 10 would be negative 1. That's not what we want. We want it to be negative 9. So we'll go back to the drawing board. 2 times negative 2 times 15. That'll give us negative 30. And when we fill in the rest of the boxes, we get negative 6 and 15. Adding those together would give us 9, but we want negative 9. If that's the case, what you want to do is change the sign. You've got the right number, you just need to change the sign. So instead of negative 2, make it negative 15. Now they add up. Negative 15 plus 6 is negative 9. Alright, so what we have right now is 3x minus 15 times x plus 2. Alright, now what you got to ask yourself is there a greatest common factor in 3x minus 15? It's a little easier to spot now because there's only two terms. Both of those are divisible by 3, so we could factor that out. 3 times x minus 5, and then the rest is x plus 2. Let me go back, make sure that we're looking at the same thing we were before. Okay, where were we? There we are. 3 times x minus 5 times x plus 2. And there it is. Same answer, 2 different methods. Alright, one for you to try. 2x squared plus 14x plus 12. Remember, the goal of this video is to get factoring out the GCF, or greatest common factor, and then factoring the trinomial. Try it out.